This is one problem in Nyquist plot model. What is the beautiful advantage of Nyquist plot is, if system contain pure time delay, how we can analyze the system stability. That is one of the advantage of Nyquist plot. So if you look at this problem, g of s h of s equal to e power minus s td t suffix d divided by s into s plus 1 s plus 2. So what is the specialty of this problem is, this contain this term. This is pure time delay. Pure time delay. So if system contain pure time delay, how to analyze the system stability? For what value of Td, the closed loop system is stable. That is the problem. So first we assume, replace this with 1 and find the phase margin. Phase margin formula is 180 degrees minus mod of angle of Gj omega g Hj omega g. What is omega g? Gain crossover frequency. So replacing this with 1, magnitude equated to 1, and solve for omega g using bisection method, you will get 0.446 radians per second. This is omega g. With this omega g, find angle, take magnitude. If you follow this procedure, you are getting phase margin of 53.4 degrees. So what is the question? For what value of Td the closed loop system is stable? So it has a phase margin of 53 plus 53.4. If this system is giving, this term if it is giving minus 53.4, then that will become 0. So this can reduce up to 0. If it is going negative, then system become unstable. So indirectly, for what value of Td, we get angle of minus 53.4. So that's why 53.4 is what? Radians. 53.4 is the degrees. This degree multiply with pi by 180, it will become radians. So this is also omega g. What is this term? E power minus j omega td. So what is angle of this is minus omega td. What is this omega is omega g. So what is omega g value already done? 0.446. And td we have to find. So this radians, this equate, solve for td, we will get 2.09 seconds. So if this constant to td equal to this much, this numerator will give angle of minus 53.4 degrees. Without that, system is giving plus 53.4, effectively it will become 0. So problem is solved like this. So this is the advantage of Nyquist plot for pure time delay. This is another model. It is a special model design problem. So g of s, h of s given. Find gain margin, phase margin for k equal to 1. So with k equal to 1, we have to find the phase margin, gain margin. Later, for what value of k, gain margin is 20 dB. So here gain margin we got 28, but for what value of k, gain margin is 20. There is another question, for what value of k, phase margin is 40 degrees. Here we got phase margin of 79. Now to get 40, what should be the value of k? So these are the questions. So to solve this with k equal to 1, so 1 divided by j omega, here 0.2, s is replaced with j omega plus 1, 0.05 j omega plus 1. And to find gain margin, what we need? Omega c. How do we get omega c? this you multiply, separate real term and imaginary. This imaginary equated to 0, solve for omega c. So omega c is plus or minus 10. At this frequency, what is the real value? That is 20 log 1 divided by this value. So 1 by, this is minus 0.2, this addition, minus 0.25, omega square is 100, simplify 28 dB. So this is how we got the gain margin. Then to find phase margin, what we need? Omega g. Omega g, how do you find? This magnitude is equated to 1, and solve this 6th order polynomial is coming. 6th, 5, 4, 3, 2 equal to 1. Use bisection method, solve for omega g. With this omega g, 180 minus mod of angle. So this will give 90 degrees. This is tan inverse 0.2 omega g. Omega g is this, like that. So you are getting phase margin of 79 degrees. So it's a normal procedure. How to find omega c, gain margin. How to find omega g, then phase margin. This is standard question. How to find gain margin, phase margin with k equal to 1. What is next? For what value of k, gain margin is 20 dB. So previously 28, with k equal to 1, 28. To get 20, what should be the value of k? So how that can be done? 20 log 1 by a is equal to 20 dB. Because what we need is 20 dB. So what is a value should be 0.1. That a value is 0.1. But here what is this real value? Real value is 1 by minus 0.25 omega square 100, which is equal to 1 by minus 0.04. So this distance is 0.04. With the 0.04, we are getting 28 dB. To get to 20 dB, what is the how much factor? We have to estimate. So 0.04 into some factor, this value should be equal to 0.1. 0.04, if we multiply it with some unknown x, it will become 0.1. So what is x value? 2.5. That means k earlier 1, 2.5 times. So what should be the value of k? 2.5. So if k equal to 2.5, this value will be 0.1. Then a equal to 0.1, it will become 20 dB. So that's how you can adjust the value of k to get the required dB. Then other question, for what value of k, phase margin is 40 dB. What is phase margin formula? 180 minus angle equal to 40 degrees. To get this 40, what is the omega g? So you have to solve this equation for omega. We are getting 4 radians. 4 radians. So this 4 is nothing but omega g. Okay. Previously omega g is 0.84. Now omega g should be 4. So this the red line, here you should get 40 degrees. Previously 79, now it should be 40. So OA, this is OA prime. So what is the factor? It should increase. Now find out OA first. OA means what is this distance. So Gj omega Hj omega at omega equal to 4. Simplify 0.191. Now OA prime by OA. What is OA prime is 1 because it's a unit circle. 1 divided by 0.191, so 5.24. So k should be increased to 5.24. So if it is plot is passing like this, if this plot is passing through like this, then only you will get 40 degrees. So previously going like this, how much time it will k increase so that this plot will go through this point, then you will get the 40 degrees. So OA should be increased by this factor. So that's why OA prime by OA. OA prime is anyway 1. This OA value we have done. This is becoming 5.24, so k is equal to 5.24. So this is a little bit tough and important, but exam BTech point of view may come, may not come, but it's a one important model. So that's why it's all. So with this, Nyquist plot is done.